The open-close principle states that software entities such as classes, modules, functions, etc. should be open for extension, but closed for modification. This specific example is from Wikipedia. This slide demonstrates how the open-close principle can apply in a graphic notation. It says here below, open chest surgery is not needed when putting on a coat. Likewise, when you extend your software, you should not need to go and dig around in its internals just to change its behavior. You should be able to extend it by adding to it with new functionality and new classes, new functions, without the need to change your existing classes and functions while still achieving new behavior. So the open-close principle offers up this sort of conundrum in that it's stating that things should be open to extension. New behavior, changes to behavior can be done in the future, but yet closed to modification. What does that mean? That means you shouldn't need to change the source code or the binary code. You shouldn't have to recompile the existing pieces of your application necessarily in order to achieve this. Dr. Bertrand Meyer originated the term open-close principle in his 1988 book, Object-Oriented Software Construction. So how do we do this? How do we change behavior without changing code? The key is to rely on abstractions. Once we start to rely on abstractions in our code, there's no limit to the number of different ways we can implement that abstraction, and thus no limit to the number of ways we can change the behavior of the code that's using these abstractions. So what do we mean by abstractions? Well, in .NET, abstractions include interfaces as well as abstract base classes. In procedural code, we can also achieve some level of the open-close principle using parameters. Let's look at an example of some code that's been written in such a way that it is not closed to modification, nor is it open to extension without having to hack at the actual source code.